All right, let's jump right in. For the past few years, we've gotten used to AI being this incredible master of words and pictures, right? It can whip up a poem, design a logo, and answer pretty much any question you throw at it. But, and this is the big but, that was just the opening act. The next massive shift? It's already here. AI is learning how to do things out in the real world.
I mean, think about it. We've all seen an AI that can think. It generates text, it writes code, it makes images. That's the AI we've all come to know. But the real revolution, the one that changes everything, starts when that intelligence breaks free from the screen and moves into the physical world, taking action and making decisions all on its own.
And look, don't just take my word for it. This isn't some far-off science fiction fantasy. A huge 2026 trends report from the consulting giant YE puts it pretty bluntly. AI agents have long since ceased to be experiments. They're moving out of the research lab and into the real world, becoming productive, valuable tools for business right now.
And that brings us to our first big idea today, what we're calling the agent revolution. We're literally watching AI grow up, evolving from this fascinating curiosity into a core business tool, an active participant in our economy.
So EY actually breaks this all down into two massive, interconnected trends that are going to define the next couple of years. First, you've got the agent revolution. You can think of this as AI getting a job, autonomously handling all these complex digital workflows. And then there's physical AI. This is AI getting a body, controlling robots and machinery out in the real world. Now, that second trend, that is arguably the most exciting frontier in all of technology right now, putting real intelligence into the physical world. This is the moment AI stops just seeing pixels on a screen and starts to actually understand the physics of a room. And this slide really nails the difference. The digital AI we're used to learns from static data, tons of text and images. But this new embodied AI, it learns by doing. It interacts with the world through sensors, it learns from trial and error, a lot like you and I do, actually. But, and this is a huge but, getting there is incredibly hard. The single biggest challenge is what engineers call the simulation to reality gap. See, a robot can perform a task perfectly, 1,000,000 times in a neat, tidy, predictable digital simulation, but then fail the very first time it encounters the messy, unpredictable chaos of the real world. And this is absolutely crucial. You can't just set it and forget it with this stuff. When a chatbot makes a mistake, okay, it's maybe a little inconvenient. But when a physical AI fails, that could mean damaged equipment, or worse, a serious safety issue. That's why expert human oversight is completely non-negotiable here. You have to ensure these systems are safe and trustworthy long before they're ever deployed. So if physical AI is the what, then what's the how? What's the engine that's actually powering this massive shift? Well, the answer is kind of surprising and a little counterintuitive. It's not about making bigger and bigger AI models, but actually smaller, much more specialized ones. So let's meet the small language models, or SLMs. For years, all we've heard about are these giant LLMs with hundreds of billions of parameters. But SLMs are the opposite. They're lean, they're super efficient, and they're optimized to do very specific, structured tasks really, really well. Think of them as the specialists, not the generalists. So why does this matter so much? Well, the answer is right here on this chart, and it comes down to one thing: pure economics. For all those routine structured tasks that make up most of what an AI agent does, these SLMs offer a staggering 10 to 30 times cost reduction. That's not just a little butter, it's a total game changer. And it's this economic shift that takes the agent revolution from a cool possibility to an absolute inevitability. So how are companies actually putting this into practice? They're building what you see right here, an AI dispatcher. The best way to think of it is like a really smart manager. When a task comes in, the dispatcher instantly routes it. The simple, repetitive jobs, they go straight to the fast, cheap SLMs. It's only the really complex, creative problems that get escalated to the big, expensive LLM. It's all about using the right tool for the job. Okay, so that's all the theory. Let's look at a real-world example of a major company that's putting this exact playbook into action as we speak. We're going to talk about Veeva, a massive software provider for the life sciences industry.
This timeline really tells the whole story. Veeva started back in 2019 with a pretty simple AI assistant. But just look at the acceleration starting in 2024. They launched advanced bots, they formalized their whole AI agent initiative, and now they're planning a full rollout of these specialized agents across
their entire platform by 2026. I mean, the pace here is just breathtaking. And the impact here is anything but trivial. Viva is projecting that these AI agents will create a 15 to 20% efficiency gain across the entire life sciences industry. This is proof that agentic AI isn't just another tech upgrade, it's a fundamental rewiring of how work actually gets done. So let's bring this all together. What does this mean for businesses? Let's try to distill everything we've talked about into a new playbook for how to think about AI, starting with the most important decision. Which models should you actually use? So, rule number 1 of the new playbook, use the right tool for the job. This little guide, which is based on research from Archive, makes it pretty simple. Use a big, expensive LLM for that complex, open-ended, creative reasoning. But for the vast majority of business tasks, where things like speed, cost, and reliability are what really matter, the specialized SLM is just the obvious winner. And here it is, the 4-step blueprint that companies are using to make the shift. First, they just log their AI usage to find all those routine, high-volume tasks. Second, they fine-tune specialized SLMs to absolutely crush those tasks. Third, they build that AI dispatcher we talked about to route all the requests intelligently. And finally, step 4, they move to a system where the SLM is the default, using those expensive LLMs only as a fallback. So we'll end on this thought. We've just seen that AI is basically developing hands through physical robotics, and it's developing specialized brains through these small language models. The question this leaves us with is a really big one. Now that AI has these new capabilities, what tasks, what roles, what jobs is it going to learn to do next?